Okay, we're back for problem number 3 of a problem that we're going to be looking for specific heat capacity. Now, in the chapter, or at least on the PowerPoint, we were told what this formula is for the specific heat capacity of a substance. Okay, let me see. I'm going to go ahead and that. C is the specific heat capacity. That's the letter that represents it, is equal to Q divided by M times delta T. So divided by the product, M times delta T. So you have to multiply those two things first, then you divide that Q. That'll give us answers of Q are the units in joules, and M is in grams, and delta T is in degrees Celsius. So we'll, have the units of joules per gram degrees Celsius. And this comes actually from the equation Q is equal to M times C times delta T. Let's just solve for C. And so both sides, what you do is you divide by M and delta T. They cancel on the right, and you end up with them not canceling on the left. And that's how you end up with this equation. Okay, so that's how we got that. And basically here what we need to do is just go ahead and plug and chug, it looks like, at this point. Let's see, let me go ahead and change the color on the ink here to show our knowns. So we're given 85.2 grams. That would be our mass. That goes right over here. We're given a Q, which is 3135 joules. So Q heat is in joules. And we're looking for a delta T. And the delta T, we can use 25 degrees Celsius and 78.3 degrees Celsius to get our delta T's. Okay, so that seems to be the plan, the battle plan here. Let's go ahead and do that. First thing, let's go ahead and calculate what delta T is. How much is temperature going to change? Remember that delta T is T final minus T initial, the final temperature minus the initial temperature. So we're going to go ahead and put in the final temperature, 78.3 degrees Celsius, minus 25 degrees Celsius. So it started off at 25 degrees Celsius, went to 78.3, and we're going to be going ahead and taking the final one, subtracting from the initial. And if we do that, we find that we end up with a temperature change of 25, 50, what do we got? 53.3 degrees Celsius. Okay. And so I'm just going to double check it because I was doing that in my head and looked easy enough, and yeah, that's right. Sometimes when they're easy we tend to get a little lax, so double check it. So here's our delta T. All right. So now we have our Q, our M, and our delta T. So let's go ahead and see what it is. So our Q is 3,135 joules. That's our Q. Divided by M, the mass, 85.2 grams, times the delta T, the temperature change, is 53.3 degrees Celsius. Right? You know what? I didn't like how that looks. Let me go ahead and just get rid of all that here. I guess that's good enough. .3. I don't know if that's much better, but okay. I guess I should extend that out. All right, so I'm going to take 3135 joules divided by 85.2 grams and divide it again by 53.3. Once again, you can do these calculations in different ways. You could take the 85.2 here and multiply it by 53.3 first, and then whatever you get in the denominator, you can divide that. You can divide 3135 by that. Or the way I like to do it is, for everything that's in the denominator, I divide it in individually. So I will take 3135 divided by 85.2, get an answer, and then divide it again by 53.3, get an answer, and I get an answer of 0.69. 0.690. Okay, is the numerical part of my answer. And remember, we need units. You'll notice that, oops, I messed up here real quickly, so let me go ahead and fix that. The units for delta T should be degrees Celsius. So if we have our units here, and now I'm going to do this in green, or let's do it in red here, units. I have joules on top, they don't cancel with anything. I have grams here, they don't cancel with anything. I have degrees Celsius here, they don't cancel with anything. So my units for my answer are going to be in joules per gram degrees Celsius. And you know, whenever you see the specific heat capacity of something, you'll notice that those are the units, joules per gram degree. They don't always have to be joules per gram degrees Celsius. Sometimes they're joules per kilogram degrees Celsius, some type of mass. And sometimes it can be degrees Kelvin. Turns out that a degrees Celsius, degrees Kelvin in this case could be the same because we're talking about differences in them. So that would be another set of units you can use. All right, we just plug them in, and there is your answer. Ooh, boy, I'm all twisted today. Maybe that's the way I'm holding this this board here. But yeah, hopefully this was straightforward. Once again, all the three problems that we worked with today basically came from this equation. This is the one equation that we really learned in this section. Q equals to m times c times delta t. You can solve for any of the variables. There's four variables: the q, the m, the c, and the delta t. And if you've got three of those four, you can solve for the fourth one. Here we solve for c, the specific heat capacity. And remember what the specific heat capacity is. It's telling you how much energy, how many joules does it take to warm up 1 gram of this substance and warm it up 1 degree Celsius. Okay, so you're taking a little chunk, 1 gram of this thing, and you're heating it up 1 degree Celsius. The question is, how many joules does it take? And that's what you're finding here. The higher the C, the bigger the C, the harder it is to heat, or at least to get to increase the temperature, because it takes more joules. The smaller the C, did I just lose that line? Smaller the C, I should do it down here. I think I've hit something over here I can't say. The easier to heat to a higher temperature. Okay, and that's what the implication is for this specific heat capacity. All right, once again, hope that was helpful with the sample problems that you'll be working with.